Let's take a look at how to linearize a data set. This happens to be the first problem from this problem set. The first step to linearizing a data set is plotting a graph of the data and observing its shape. When you plot time versus position as follows, independent variable, dependent variable. This particular graph is shaped as follows. Step one, plot a graph, observe its shape. Now that you know what shape the original data is, you have a sense of what the likely relationship is. Using the variables on this graph, I know that it is probably this type of an equation, because this is shaped like a parabola and this is the general form of a parabolic curve. Okay, next step. Let's move on, and we're going to modify the original data set in a fairly straightforward way. The modification, though, takes place according to what's on the reference sheet. Graphical Methods reference tells me that if I have a parabola, I'm supposed to square the independent variable and use that data in the plot. Square the independent variable, dependent variable, just for your reference. So I'm supposed to square the first one, t squared. Make a new data column. 0.1 squared is 0.2 squared. I hope at this point you're fast forwarding the video. With a new independent variable, replot the graph. Replot the new independent variable versus the dependent variable. You'll note that my t squared column takes the place of my t column. When you plot this data, you'll get data that is a straight line or is very, very close to it. It turns out that the slope of this straight line is the a value in this graph. So check this out. Remember, there are many ways to determine the slope of a line. If the line that fits through all these points perfectly passes through all of them, you could just find the slope of this line. So let's find the change in dependent variable. I'll go from the biggest to the smallest. So that's going to be 75 minus 0.03 divided by 25 minus 0.01. This is the slope of that straight line of t squared versus x. It's 3. This graph has a slope of 3. Now this I did separately in Desmos or graphical analysis software. This means that my equation is dependent variable x equals a times independent variable t squared. Now what's really kind of cool about this process is if you had applied a curve fit to this graph using some more advanced software, you would have gotten that number x equals 3t squared. But we just did it by hand here. And so this kind of uncovers the mystery of where that comes from. Your goal is to modify the independent and dependent data until you wind up at a linear graph, because we have the algebra skills to find the slope of a straight line. We do not have the algebra skills, well, the calculus skills, to find the rate of change of this curve. So we keep going until we find a graph that we know how to deal with, a straight line. I knew to square this column because I was able to classify the original shape as one of these four. Now that kind of presupposes me giving you this information. And in this class, if we ever see a relationship that's not one of these four, I'll add it to the data table for you. Just a reminder, you're using this column to tell you how to manipulate your data so that you hopefully wind up at a linear graph. My challenge to you is now go on and do these other graphs. You want the exact equation output, the mathematical expression. Best of luck.